So hi guys, welcome back to my channel. So this is gonna be the fourth video in the low level design playlist, and in this video we are going to unpack the abstract factory pattern. Okay, we are going to deep dive into how this pattern functions within the system design. Now before this, if you haven't watched my factory pattern, please go and watch, because in that pattern I have explained you in very detail that what is this pattern all about and what are the components that we are going to use to implement the factory pattern, with two code examples and all the components, and that too in very detail with the UML diagrams and with the code examples also. So please go and watch. Why I'm saying this, because abstract factory pattern is nothing but an adjunct of the factory pattern. It means that it is an extension of the factory pattern. The components that we are going to use in this abstract factory pattern are going to be very similar to what we have used in the factory pattern. Okay, so this is it. So let's start with this. So before that, what are the contents that I have with me in order to explain this abstract factory pattern? Let me show you first. Okay, I have the definition with me, I have the differences with me, I have the precise descriptions, the difference between abstract factory and factory pattern, I have the components with me. Okay, and I have the UML diagrams which explains one of the code examples. I have the component summary table which explains about the components that anybody can use in order to implement the abstract factory pattern. Also, I have the real life examples like how we can leverage the use of abstract factory, okay, and when to use the abstract factory, some UML diagrams of another code examples, and the real benefits. Okay, so let's start with the definitions. Okay, so now let's dissect the core principles of this architectural pattern. Okay, so starting from the definition, so it provides a way to create, okay, let me change the pen before that. Okay, so it provides a way to create families of related and dependent objects without specifying their concrete classes. Okay, what's the main agenda of this pattern is, it is a way to create families of related and dependent objects. Just remember this throughout the video. Okay, without specifying their concrete classes. Whenever I'll say the concrete classes, it means that I'm talking about the product interface. Now moving further, this means that the client code never writes the new window button, new UX button directly. You'll soon come to know why I have taken this examples. Okay, it never mentioned the concrete classes by name. Now moving further, $1 million question is, factory and abstract factory are same? Now factory method, if I talk about the factory method, it defines an interface for creating one object. Remember this, but let the subclass decide which class to instantiate. Moving towards the abstract factory, it provides an interface for creating a families of related objects. Just focus. What I've told you here is, just remember this line. It is a way to create a family of related and dependent objects without specifying their concrete classes. Same goes with here. It provides an interface for creating families of related objects without specifying their concrete classes. Now, unlike the factory pattern which deals with a single product variant, the abstract factory handles an entire suite of related objects. I think it is clear, a bit clear. So I'm guaranteeing that as soon as we'll move forward and as soon as we'll start explaining all the descriptions, all the components, you'll start getting a clear picture of abstract factory, that how it works, what is the main agenda of this abstract factory pattern. Okay, now the three words that change everything is family of related, means creating a family of related objects. Okay, now let's have the description of these two. So factory pattern is concerned with one product. You have one creation method, one product interface, one product being made. The pattern's job is simply to defer the concrete classes gets instantiated to a subclass. Okay, in the code example, you'll get clear for this line what it's trying to say. Whereas abstract factory is concerned with a group of products that belong together. It doesn't just ask how do I create the things. It asks how do I ensure that everything I create is from the same compatible system. Okay, as I have already told you that abstract factory handles the entire suite of related objects. Okay, who creates the entire ecosystem of object, and how do I guarantee that all are compatible with each other. Now okay, let's walk through the components of abstract factory. Okay, there are in total 5 components that we'll be using in order to implement the abstract factory. Now let's deep dive one by one, starting from the abstract product interface. So this is the code example that I have used in order to explain this abstract factory, and each components I have used one by one in order to showcase that this way we can easily implement the abstract factory pattern. So we have the abstract product interface as a first component. So you'll see here one interface per product type. Here we can see there are 2 interfaces and one method each of this contains. Now it defines what a product can do, okay, not how. How handles the create products, concrete products. So let's see, this is the two interfaces that I have declared. One is set on and one is use, but it defines what a product can do. Every concrete product must implement one of these. We'll talk about the concrete product, which is the second component. So it tells what actual implementation that products have, okay, one per product type per family. In this example, I'll be using two families, okay, one is modern family, one is Victorian family. So just remember, throughout the video for this example, we'll be talking about the modern and Victorian family. So concrete product, N families means two families, and product types means M means product type. So what is the number of product types that we have? Two product types, and we have two families. So in total there will be 2 into 2, which is equals to 4 product classes. You can see here that we have, so this modern chair, modern table, Victorian chair, Victorian table, okay, we have 4 product classes. This way you can confirm that you are going on a right way, okay. So here 2 families, 2 types, 4 concrete product classes. Client never references these directly, okay, only the concrete factory knows about them. Now we'll see what are the concrete products. So this is the modern chair, okay, this is the modern chair which implements chair. Just because it implements chair, it has to gives the implementation of sit on. It has given sitting on modern chair. Same as modern table implements table, it has to give the implementation of use. So it is the product class, modern chair, modern table. As I have told you that 2 families, 2 types each. So for family 1, which is modern family, I have 2 product types. For family 2, I have 2 product types. Same goes with Victorian chair, Victorian table. Just because it implements chair, it has to give the implementation of sit on, and same goes with table also. So moving to the third component, which is nothing but the abstract factory interface. So this is the heart of the pattern. Why I'm saying this? Once I'll dry run the code, then you'll get to know that why I have told that this is the main heart of this pattern. Same goes with the factory pattern also. And similarly, we are talking about the abstract factory pattern also. This abstract factory interface is the heart of this abstract factory. This is the game changer, okay. It declares one creation method per product type, one creation method per product type, okay. What is the product type? We have 2 product type, so here will be 2 creation method. Does not care how products are created, only what. Client depends only on this, never on concrete factories. Same here also, the point was written, only the concrete factories knows about them. Client never references these directly. Client depends only on this, so client depends only on this, never on concrete factories. Adding a new family, 0 changes here. This also I'll be giving you the example how with this pattern that we have used in order to implement a problem is how much resilient. Like whenever in future there is new requirement came, how with following the solid principles, how we are going to implement that also I'll be explaining. So now moving to the fourth component, which is the concrete factories. This is also plays a very important role in this pattern. One concrete factory is equals to one complete product family. One concrete factory is equals to one complete family picture. Each create X method is a factory method internally. Each create X method is a factory method internally, okay. Adding a new family is equals to adding one new class here, 0 edits to existing code. Open close principle satisfied. So this is the modern furniture factory which implements the furniture factory. Now just because this implements the furniture factory, it has to give the implementation of create chair and create table. Now what is the role of create chair and create table is the return type is chair and table. So now the main definition of this pattern is it provides an easy way to create family of related and dependent objects without specifying their concrete classes. Now move to here. What concrete chair is returning is new modern chair. Inside the modern furniture factory, let's pick it as a whole factory which produces the modern furniture. Now just because it produces the modern furniture, so if I'll use the create chair, it will create the modern chair. When I'll use the create table, it will give the modern table, just as here, okay. Modern chair, modern table, okay. These are the product classes, same as that of the Victorian furniture factory. Just because this is the Victorian furniture factory, it will only care about the Victorian chair and Victorian table. Moving further, only place modern chair is ever instantiated. These are the annotations that I have used. I'll be explaining, okay. Let me complete all the components first, then I'll be running it, and then I'll be explaining how this is working and how resilient the code is. Moving to the 5th and 6th component. Main method here plays both roles. What is composition root? The only one if and else in the entire code bit decides the family that which family we are gonna use, okay. The client will decide, there will be only one if else. So in that if else, we can either, if I'll talk about the production code, so what happens is, so from the config table, which family we intend to implement, okay. So this only one if and else is the deciding factor that what family we are going to continue with. And if I'll talk about the client code, it only depends on the furniture factory plus chair plus table, has zero knowledge of the modern plus Victorian concrete classes, fully portable, swap factory, zero lines of client logic change. Okay, so let's walk through the implementation that I have done in the client code. So what I'm doing here, this is the abstract factory, as I've already told you here, abstract factory interface. Okay, now in the abstract factory interface, we are creating an object of modern furniture factory. What? Modern furniture factory. This interface, we are storing the object reference inside this interface. Okay, just because this modern furniture factory is implementing the furniture factory, then it allows us to store the object of this modern furniture factory as a reference in the furniture factory. I hope this is getting a little bit clear what I'm talking about. Just because modern furniture factory implements furniture factory, you all can see here, modern furniture factory implements furniture factory, then it allows us to store the object reference of this modern furniture factory inside the furniture factory as a reference. Okay, I hope this is getting clear. Now, once I have done this, so my factory is pointing to new modern furniture factory. Now, chair is equals to factory dot create chair. Let's move to the implementation of create chair. Now, where is the create chair? Okay, now there is the confusion that which create chair I need to call, this one or this one. So it will ask the code or the JVM that which object it holds. So it holds the object of modern furniture factory. Then this factory will instantiate call the create chair. So factory dot create chair of the modern factory it will return. So it will return new modern chair. Now chair is equals to new modern chair because factory dot create chair is returning an object of modern chair. Okay, you can see new modern chair. So again the same example what I have explained, furniture factory is containing the object reference of this class modern furniture factory. Why? Because modern furniture factory is implementing this furniture factory. Same goes here. Chair is storing the reference of new modern chair. Why? Because modern chair is implementing chair. I hope this is getting clear. So chair is equal to new modern chair. Inside the chair we are storing the reference of new modern chair, and also goes with the table. Here we have new modern chair, here we have new modern table. How new modern chair and new modern table? Just because of this line, new modern furniture factory. Okay, so in the chair reference we have new modern chair, in the table reference we have new modern table. Now directly calling the methods. So chair dot sit on. Okay, if I'll call the chair dot sit on, just because we have the new modern chair and new modern table, so new modern chair dot sit on, new modern table dot use, you will see that if I'll run the code, you'll see it will print the sitting on modern chair and using the modern table, sitting on modern chair and using the modern table. So this is how implementation is working. Let me again walk you through the code one more time so that it gets more clear. Now starting from the component 1, abstract product interfaces, one interface per product type, one interface per product type. We have two types of product. Now moving to the concrete product and families. In this example we have implemented two families, modern family and Victorian family. So two families, and how many product type we have? M product type means two product type. So we have to implement 4 concrete classes. Okay, modern chair, so for one family, modern chair that implements this chair, modern table that implements the table, Victorian chair that implements the chair, Victorian table that implements the table. So now giving the implementation of all the methods that are there in the interface, moving towards the abstract factory interface. This is the main heart of the pattern. Now declares one creation method per product type. How many product type we have? We have 2 product type. So there will be 2 creational methods, create chair, create table. Okay, the only role of this furniture factory is to mention the abstract factory methods which the client will leverage in order to get the objects. So now moving to the component 4, concrete factories. One concrete factory is equals to one complete product. As you can see, modern furniture factory is the package of complete product. Okay, modern chair, modern table. Okay, Victorian furniture factory implements furniture factory, create chair, create table, which is giving or returning the object of Victorian chair and Victorian table. Moving to the client and composition route. Composition is just because the if and else block in order to decide which family we are gonna continue with. Okay, so talking about the client code, so furniture factory, it's the interface. It is storing the object of modern furniture factory. Why? Because modern furniture factory implements the interface furniture factory. You all can see here. Okay, now just because the factory is now containing the reference of this object. So factory.createChair, factory.createTable. We'll go to modern furniture factory, factory.createChair, factory.createTable. It will return modern chair, modern table. Chair is equals to new modern chair, table is equals to new modern table. Now same goes here. Chair is the interface and new modern chair. So in the interface, we are storing the reference of the object of new modern chair. Why? Because modern chair is implementing the chair interface. Same goes here. Table is equals to new modern table. In the table, we are storing the reference of new modern table. Why? Because modern table is implementing the table. Now chair and table. So if I'll go chair.sitOn, table.sitOn, just because it is modern chair, modern table, so it will call the modern chair implementation of sit on and use. I hope this is clear. Now the main thing. So now you all can observe that how this approach decouples the client from concrete classes. Okay, and you all can notice that how this pattern facilitates creating object families without specifying their concrete types. Okay, so I hope you all are clear how the code examples are working. Okay, how this code is working. Now I want to show you one thing, that what are the benefits of this. Okay, then I'll move to the second code examples, then it will be more clear. Okay, the real benefits is swap entire family in one line. As I've told you, just remember this new Victorian furniture factory. Why I've told you? Why? Because everything below this is untouched. Whenever the new requirements came, let's say I only have the modern furniture factory. In future, I have the new requirement to implement the Victorian furniture factory. Then what are the changes that I need to do in order to execute the code? So the only thing that I need to do is I need to replace the Victorian furniture factory with the modern factory. Okay, now if I'll run this, the entire suite of related objects will be called. So I'll be sitting on the Victorian chair, I'll be using the Victorian table. You can see that how smoothly the code is handling by just only changing this line. Okay, nothing else. So nowhere I have done the changes in order to switch between the two families. Okay, now moving to the second advantage, adding new family means zero existing code change. You all can see here that tomorrow if you need an art deco furniture, you only add this. Let's say if you want art deco furniture, then what you'll do, you'll add two product types. Okay, family Victorian, same as this, I'll copy paste, and art deco table, using the art deco table. Now one more thing that we need to do. So we have done this change. Okay, I have added this. Instead of Victorian, it will be art deco. Now you all can see, as the rule of this is, so we have shifted from two families to three families. One is modern, one is for Victorian, and one is art deco. So three families, two types, it will be 6 concrete classes. So 1, 2, 3, 4, 5 and then 6. Now what are the next changes that we need to do? So in art deco furniture factory, we need to implement. So first change is I have declared the concrete products of that family. Now I need to declare the factory. Okay, I'll be declaring art deco table. That's it. Okay, so just two things we have added. So modern furniture factory is still untouched, Victorian furniture factory is also untouched, client code is also untouched, furniture factory interface is also untouched. The only thing which now we need to replace is, instead of Victorian furniture factory, I'll be replacing this with art deco furniture factory. Now if I'll run, you'll see that the whole suite of art deco is executed. So sitting on the art deco chair using the art deco table. So now I hope this is clear. I hope the code example is clear and all the advantages of this using the abstract factory pattern is also clear. Okay, so now let's have a view on UML diagram of that code example that I have explained. So this is the client code. By the way, we are going from bottom to up. So this is the client code, means the main code. Okay, this is the abstract factory, means how many factories we have. In this I have taken the example of so in this I have taken the example of modern furniture factory and Victorian family. I haven't included the art deco. So this is the factory that is containing the abstract factory methods, which means this is the main heart of the abstract factory pattern. So it has two implementation. So it depends on how many product types we have. So just because we have two product types, which is chair and table, we have the two create methods, create chair and create table. So modern furniture factory is implementing this interface, which is furniture factory. So just because this implements, it need to give the implementation of create chair and create table. So it is giving the implementation of create chair and create table, as it is returning the object of modern chair and modern table. Same goes with Victorian furniture factory. So just because it is implementing the furniture factory, it is giving the implementation of create chair and create table, which is nothing but returning the object of Victorian chair and Victorian table. Now moving a bit more up, which is concrete products. Okay, so we have two concrete products. Okay, so just because modern chair is implementing the chair, it need to give the implementation of sit on. Just because Victorian chair is also implementing the chair, it needs to give the implementation of sit on. Modern table implements table, give the implementation of use. Victorian table implements table, give the implementation of use. So these are the concrete products, this complete layer. These are the abstract product interfaces. These are the concrete factory, which ensures that we are actually working with entire suite of this family. Okay, this is the concrete factory. This is the abstract factory, which is the main heart of the abstract factory pattern, and this is the client code. Okay, so now let's move and let's see the concise. Okay, so this is the components that we are using in order to implement the abstract factory pattern. So first one is the abstract factory, only one interface. It declares creation methods for each product type. How many product types we have for that example? 2. That means we'll be having two abstract factory methods, but wrapped in one interface. Now concrete factory, one per family. In this code example, we have used 3 families, so it will be 3 total families. Okay, abstract product interfaces, it depends on the use case how many product type we have. Okay, concrete products, so n families into m types. So in this example, we have 3 families, and depends on how many product type we use. So the formula is n families into m types. So you need to implement n into m product classes or concrete products. Now this at last we have the client and composition route. Okay, so let's see another example, which is logistic example, which is implementing abstract factory pattern. So we have 3 product interfaces based on the business type. Okay, can you guess how many concrete products we need to implement? No. Why? Because till now you don't have any knowledge of how many families we have taken for this example. So let's see how many families we have taken for this example. So we have concrete factory, road logistic, sea logistic and air logistics. So total 3 families we have used. So 3 families, and that too 3 product types. So how many concrete products we need to implement? 3 into 3, which is 9. So you can see truck, road driver, road warehouse, ship, ship captain, seaport, plane, pilot, airport. So in total there are 9 concrete products that I have implemented here, and this is a very simple, that truck is implementing transport, so you need to give the implementation of deliver, operate and store within their respective classes. Now moving to the abstract factory. Now can you guess that how many methods we need to implement in this logistic factory? As I've already told you that it depends entirely on the product interface, how many product interface are there. So there are 3 product interface, so we need to implement the 3 factory method, which is transport, create transport, driver, create driver, warehouse, create warehouse. Now moving to the concrete factory, as we have used 3 families, so we have implemented 3 families in this code example. Now road logistic implements logistic factory, so it need to give the implementation of all the 3 methods that are there in the logistic factory. Okay, sea logistic factory, same, implementing logistic factory, so you need to give the implementation of all the 3 methods. Air logistic factory, it also implementing logistic factory, you need to give the implementation of these 3 methods. Okay, so now let's move forward. We can see here, this is the logistic service. Actually this is the client code, and this is the composition part that we are leveraging. Okay, I'll explain the both flow. Okay, so this I'll explain. Okay, don't worry. First let's start with this. This is the composition route. Why? Because the mode is C. That means if it is C, the factory, which is nothing but I guess logistic factory. Okay, so logistic factory is equals to which family I want to use depends on the config table. Here I have given C, so based on the if else, it is C. It has returned me the new logistics factory. So logistic factory is equals to new C logistic factory. Okay, so now just because C logistic factory implements the logistic factory, we can store the object of this as a reference in the logistic factory. I hope this is clear. Now logistic service, this class we are passing the factory. Okay, this is the main part. Okay, now as I have passed as a constructor factory, so what it will do? Transport, driver and warehouse. It will create 3 objects. Okay, 3 objects. What it will do? we are currently at this line. Okay, what it will do, it will instantiate the transport. Okay, transport is equals to create transport. Now just because we have came to C logistic service, it will go to C logistic service. Okay, and it will see create transport, create driver, create warehouse. Okay, create transport, create driver, create warehouse. It will return new ship captain, new seaport. Okay, let's see, it will return ship, sea captain, seaport, ship, sea captain, seaport. Now with the help of transport, now again one thing to be noticed here, it is returning new C. So in the transport is equals to new C. Where is okay, so just because we have used the C logistic factory, so C logistic factories create transport. What it is returning? C logistic factory create transport. It will return the ship. We are storing it inside the transport. Okay, let's see the transport. Okay, so for the C logistic service, we'll see here, so ship, it is returning ship. So just because ship implements transport, it means that we can store the object of this ship inside the transport. Okay, I hope this is clear. So same goes with all the three methods, this and this. Now transport, driver and warehouse have their respective objects stored as a reference. Now next point, service dot plan delivery. So service, which is of C logistic factory, service dot plan delivery. So what it will do, the plan delivery will call transport dot deliver, driver dot operate and warehouse dot store. But which one to call? So we have the C. Let's see what it is returning. Ship, sea captain, seaport. Ship dot deliver, we'll see above. Ship dot deliver, it will return delivering via C in ship. Next thing, what it is returning? Create driver, sea captain dot operate. Let's move forward. So let's move upward. Sea captain dot operate, sea captain operating ship. Now let's move forward. Create warehouse. What it is returning? Create warehouse, it is returning seaport dot store. Seaport. Okay, seaport dot store, storing in seaport. Now if I'll run this method, if I'll run the complete code, what it will return? Okay, let's see. It needs to return all the part which belongs to the C logistic factory. Let's see. It has returned delivering by ship in C. Let's see. Let's verify. Delivering by ship in C. Sea captain operating ship. Storing in seaport. Can you see that how this abstract factory pattern is guaranteeing that if you once have declared that you want to work with one family, then it will guarantee that I'll be returning all the methods related to that family. So now if I want to change it from C to road, then what will happen? I'll save, I'll run this, I'll put in Java application. You can see delivering by road in truck, road driver operating truck, storing in road warehouse. You can verify here. If you'll see the implementation of road, okay, delivering by road in truck, road driver operating truck, storing in road warehouse, the three methods that belongs to the family of road. Okay, you all can see here where are the family, okay, road logistic factory. All the methods that is returned in the console is belongs to the road logistic factory because we have used the road. I hope now this is getting clear. You all can see this example that this is the abstract factory, which is the interface which create the three abstract factory methods depends on what are the product types that we have used. Okay, implemented by each and every families. Okay, and produces the concrete products and which is further used via clients. Okay, I'll not deep dive into this because I have already given you the explanation from the first example and I've already explained the UML diagram of the first example. You all can see and you all can get a clear idea that how it is working, how the flow is working. Okay, so now the main thing to observe here is, okay, so why I have given you the example of new UX, new window button, new UX button, because it is very frequently used in these examples. I'll show you that when to use abstract factory in real life is cross-platform GUI. A GUI toolkit might need to create buttons and text field that belongs for different OS. Okay, so different operating system have their different interfaces. Okay, so the abstract factory ensures that all the UI components looks consistent across the current operating system. I hope this is clear. So if you'll specify that, okay, I need all the methods which belong to this operating system. So this factory pattern ensures that it is returning the entire suite of the products which belongs to that current operating system. Now themed application. So application with light and dark themes often use abstract factory to create components. Example, buttons and menus match the selected theme. So let's say I have selected the theme A Okay, so this factory pattern ensures that it will return all the methods that belongs to this theme, means A1, A2, A3, A4. If I've selected B, then it will return all the methods that belongs to that theme, which is B1, B2, B3, B4. Now, when to use this abstract factory pattern? So when your application needs to create families of related or dependent objects, this is the first and foremost point, that is the most important point. Now moving to the second point, which is when the object creation logic needs to be decoupled from the client code. So one thing to be noticed here is that this promotes loose coupling across our entire code base, and this also gives us the flexibility to extend the system further down the line. Okay, and also one more thing is, I want to tell you that if you have watched my factory pattern, then you will remember that I have told one point, that object creation delegates to the subclass. Okay, instead of this. Okay, instead of object creation doing it in the furniture factory, the object creation is delegated to the subclass. Okay, or the subordinates. The entire responsibility of the object creation is given to the subordinates. Subordinates means the lowest ones. Okay, now when your system needs to be scalable with the possibility of introducing new families of objects, I have used one example where I have introduced one more object as art deco, and I have shown you that no single class is touched. And with this example, I have proven the first solid principle and the second solid principle also. Okay, I hope this is clear now. I hope this is a bit clear now. So for this video, okay, so I have explained the definition, the clear difference, the description of both patterns, the components of abstract factory patterns, the 5 components that I have used. 6 is just an optional that we want to use or not, but majorly there are 5 components that we are using to implement this abstract factory pattern. One UML diagram, that is the second code examples. Okay, all the component summary table I have explained, when to use the abstract factory pattern, and the UML diagram of the first example, and also the real life benefits of this example. Okay, now so I hope the complete video is clear with the 2 examples. The 2 code examples I'll be giving you in the comments, so you all can see that how it is implemented. Now to wrap things up, the abstract factory pattern. So now to wrap things up, the abstract factory pattern is your go-to solution when your system needs to be independent of how its products are created. First point, the bottom line is, using this pattern whenever you need to ensure that a suite of related objects works together seamlessly. Just remember these 2 points that I have just said. With these points, I hope every code examples, every definitions, and every aspects of this abstract factory pattern is clear. So thank you for watching and having patience. So thank you.